November 3, 9 o'clock. So the parts came from LAZADA. So there's 5 and 5. With these two, it cost 600 shipped. So now I did check the resistors, and I'm using this as a reference because it's not populated. However, there's something wrong with these values. Anyway, with these four populated MOSFET N channel, the resistors are cooked, damaged. So all of them are damaged. There's two here that's not damaged. However, mostly all of them are damaged. So I did some simple reverse engineering of how this thing works and how the MOSFET uh, N driver with this NPN and PNP, and a little bit of how this circuit works. However, I'm mostly focusing on how this system works on this side. The placement of the resistor is way too close to the MOSFET. When the MOSFETs get quite hot, the heat conducts toward the resistors, and eventually the resistors will be in that state where it really doesn't do its job because it's way too hot. And when the resistor gets too hot, whatever power rating it has initially will disappear or impacted or derated, so that they will now be easily damaged. What the designer should have done is move it away a little bit from the influence of thermal runaway, or use a higher rated resistors like these are. Let's see, with these components, I think they're rated at 0.25 watts. I can't remember, or 0.125 watts. And so, and then when it gets fairly hot, it just loses its property. So that's why they're easily damaged. And I don't know, the designer basically, quite honestly, this thing is designed to be obsolete, and these are hard to repair. So basically, one is forced to buy a new one if this thing can be repaired. The with this type of damage, the pads on the component will start to lift or lifted already. So sadly, when I will replace the component, the pads will probably lift, and now I will have to do jumper them to make it work again. I was thinking of replacing the resistor to be higher rating. However, it's not possible because the component's way too small. So I briefly spent several minutes reverse engineering the circuit board. For the fun of it, I needed to understand how the NFET or MOSFET N channel are driven. So basically, this is the driver U1. Through this drives the MOSFETs. This chip drives the FET driver, and this receives the signal from the isolator, opto isolator, then the micro. So there's a bit of a isolation of the low voltage, and the designer decided to isolate certain part of the circuit just because it's. If I was designing an inverter, I'd probably do the same thing, learn a little bit more about it. So this is the schematic that I drew up of the inverter. And this transformer is with the middle pin. It's driven by MOSFETs. This is the MOSFET driver through these PNP and NPN transistor. And basically, like I mentioned before, the drain, this is drain, and it pulses the transformer using the battery as the middle pin. So this thing is pulsing, and this part is pulsing also. So it's a mirror image of the circuit board or the circuits. So this TC4427 is microchip key A3525. I don't know. I've forgotten what it is. So these transistors are fried when these overheat. So this R6 limit the pulse current driving the gate of the MOSFET, and these are the pull down to quickly discharge the gate capacitance. So when these gets pretty hot, because these two components are pretty close to the component, they get fried, they burn up, they pop. So that's the reason why this design, they did some validation. However, they didn't really fix the thermal characteristics of the component. They just allow these two components to fry. Basically, built-in obsolescence. They could increase the rating of this component. However, just basically says, well, it is what it is. It'll just fail. So this key A3525, basically this is obsolete. So this inverter might be unable to be repaired in the future. So are these. So when I look at the inverter, there's quite a bit of obsolete part, or not to use for new design. So this is basically what the inverter look like. This gets fried from overcurrent. The component gets fried from thermals, and basically because it's switching this side and switching the other side, they all will be fried. So now I don't know if these components are fried. So now I have to buy these component, the resistors, so that I can repair the circuit board. So where I thought I would just replace the MOSFET, it turned out now I have to replace the resistors. I don't know what else to replace. I suppose one thing at a time, replace this and then see what happens. So that's what it is. Yeah. Oh well, this is life. Thanks for watching.